Okay. Hello everyone.
Good evening, sir.
Good evening. So how was your week? How was the quiz too? Okay. You guys, I already marked your assignment, assignment 2, and you can find the marks for assignment 2 in your coursework mark folder. You can go to the coursework mark folder in ULearn and you can find the marks for assignment 2. So you guys have any question regarding team project? The project, you have to compare the motto, right? So you have one project and one video. Do you have any question on that before we proceed to our class today? No question. Well, guys, very good. I have no question. So remember, you can submit one report for the whole group. Okay, the report must follow the appendix that given to you. Okay, the of the appendix, and each component has to be done or contributed by one member. Okay, if I and in the acknowledgement, okay, there's acknowledgement section, and want to know who contributed which. Okay, for example, introduction is contributed by one guy, followed by discussion, followed by experimental, abstract, and so on. Okay, conclusion and so on. Okay, so make sure the name is there. If not, the marks won't be given. If let's say in the acknowledgement, if let's say the 5 of us, okay, A, B, C, D, E in a group, and there's no mention of a name of E in the acknowledgement, then the marks won't go through for the person, okay, with the name E. All right, so be careful. Make sure all of you seen the report before the submission. Mana tahu tertinggal ke apa kan? So if your name is not there, that means I assume the group member are neglecting you because you doesn't contribute. Okay, clear? So far we will have 11 group, 11 group, and I think the assignment everyone can do, so all almost get full marks lah. It's just the question number 2. okay, which it asks what is the impedance seen by the source. So you just take the source, which is the source voltage 600 V, and you also got the source current, right? I1. You use 600 as you have the 600, and then you have the current, so you find the Z lah, 33. Okay. Other than that, I seen everyone doing good. Okay, all the question. And some number 3, so number 3 they mixed out the formula. So the formula should be N1 over N2 equals to V1 over V2 equals to I2 over I1 equals to A. So you can derive lah. Other than that, everything very good. So let's do some revision first before we proceed. And let me show you a slide. Let me add the slide first. Okay, so let's start. Share notes. Okay, so let's start with revision, brainstorming. Okay, let's start with brainstorm from what we learned last week. Okay, so how many types of motor are there? Any of you can write. How many types of motor are there? In general, overall, how many types of motor are there? Or how many category that we have? Okay, so you have some of you right here in the chat. So some say 2 cannot type, sir. Okay. Oh, you can't write. Okay, sorry. I should start recording. Yes. Okay, I apologize. Recording is start. I think now you can try. Right now, locked by moderator. Settings, pop alert, audio chat, pop alert, application language. Okay, you cannot. Okay, it's okay, no problem. So you just type here in the chat. Okay. So there's Amanda. Amanda say there's 2 type of motor. Yes, correct. There's mainly 2 category, AC and DC. Okay, so that's right. You have 2 type, and in AC, okay, you have 2 more type. What is that? What is the 2 type of AC motor? Come on, try to participate. Okay, squirrel cage, Wong, good. Okay, Iskandar, very good. One rotor, squirrel cage and one rotor. Okay, you have another name for squirrel cage and one rotor. What is that? Okay, Wong, asynchronous and synchronized motor. Yes, right. Amanda Asfa. Okay, synchronized is induction lah. Induction or squirrel cage. Okay, we call it synchronized. Okay, the asynchronized, we call it induction motor lah. Induction or one rotor as another name. We call it as synchronized motor. Okay, and the other motor is called synchronized lah. So we just have 2 types. Okay. The reason why we call induction motor and wound rotor, okay, squirrel cage and wound rotor as synchronized. Do you know why we call it this as synchronized? Okay, right. Wong is right. Anyone else? Nur Fatiha, Nur Azlina. You guys participate, try to participate in the class. Sumin Mo. What is it? Sumin. Sumin Tan. The more you participate, the more you learn. Okay. All right. So it's true. Asynchronous motor, you have the rotor speed and the synchronized speed, which not same. Okay. All right. So that's what we learned last week. Let me proceed with the slide. Okay. So as we learned last week, there are three-phase induction motor are most common in industry. Okay. It is designed by Tesla. Okay, and it was used until now. The latest version is the wound rotor, but initially the squirrel cage is the old design. Okay, it was selected because it is actually simple design, low cost, rugged, and require little or no skill maintenance, and it is as a very fractional or high horsepower. Okay, explosion free, run nearly at constant speed from the 0 to full, and any motor, okay, most of the motor, they have two components. One rotor, second is stator. Okay, stator has the stator winding, rotor has its rotor winding. Okay, and this is the winding type. And for squirrel cage, it's look like a cage type where you have a short circuited at the end. Whereas in the wound rotor, you have coil windings, okay, on the wound rotor. And most common type of induction motor, okay, there's a squirrel cage and so on. Okay, that's the theory. And when you look at here, okay, that's the theory of rotating magnetic field. Okay, when you look at your tutorial question, it asks about how the rotating magnetic field is established. Okay, so balanced three-phase winding, which is mechanically displaced 120 degrees from each other, fed by balanced three-phase source. So the motor, imagine the motor have 6 poles, okay, and you have three-phase power. So three-phase power, you have phase 1, phase 2, phase 3. Okay, you have red phase, you have blue phase, and let's say you have yellow phase. Okay, you have 3 phase, and from these 3 phase, and when you look at the current, right, voltage, so from the supply, you will have different phase. For each single line, you have different phase. For example, the yellow phase, which is later, the blue phase, which start a bit earlier, and the red phase, which start more earlier. Okay, so you can see there's a phase difference 1, 2, 3 between red to blue, blue to yellow, red to blue, blue to yellow. So all separated by 120 degree. Okay, so when it start to actually change phase, okay, when you connect this, it will appear, okay, there will be field. Okay, so under the rotating constant magnitude producing rotating with a speed. This is the speed lah. Okay, what will happen is when you supply frequency, okay, number of poles. Wait, let me show you the theory. Okay, the rotating magnetic field called the rotor winding and produce an induced voltage in the rotor winding. So when you have power voltage, okay, when you supply and you have a winding, okay, so you know any current that flow through a winding, you will have a magnetic field produced. This magnetic field, okay, on the winding, okay, will be, you have a stator magnetic field lah, okay. So this magnetic field will induce the current on the rotor now. So now you have stator and stator winding, okay. So and you have rotor example here. So when you have current pass through this winding will have its own EMF, sorry, electromagnetic induction on. You will have the magnetic field here, and this magnetic field here will induce current on the rotor. Okay, so now rotor will have its own current, and rotor also have bar, has the winding bar kan, which is short circuited. So now this rotor winding will have current also, so it will oppose. So that's why we say the rotor magnetic field and stator magnetic field combined with this factor, you will have induced, torque induced, though that will make this rotor to spin actually. Okay, so it is involving two factor. Okay, it's all basic concept electromagnetic induction, which involve stator and rotor induced voltage, induced current, induced magnetic field. All right, so that's the theory lah. Okay, so I don't want to go further because we already complete. So next, let's proceed with the assignment, sorry, tutorial. Okay, let's go to the tutorial. Okay. Everyone can see the tutorial slide. All right. So when you look here, this is the warm-up question. Okay, let's get warm up. Okay. So everyone can start do. Okay. Take out your pencil, take out a paper. Okay. Let's do the question. When you do together only you understand. Later don't complain. Test 2, you get low mark or final exam you cannot answer, extended assignment, don't complain. Okay. So now everyone take your paper, take your pen, start writing. Let's do it together. Okay, first question. Single phase 4-pole. Hello, yes, who's this? Yes, yeah. Okay.
I'm sorry, sir.
It's okay. Advertisement. It's okay. All right. So proceed. Look at the question. A single phase 4-pole induction motor. Okay, it's given the data. The input power is 373. Okay, the input watt, and then 230 volt. Frequency is 50 hertz. Input current is 2.9 ampere. Your efficiency is 0.71. Your speed is 1410 RPM. Calculate the output power of the motor. So they want you to calculate the output power. So in motor, input power we label as PE. This one we call it input power. Output power we call it PL. Output power. Okay, and the information here, efficiency. Efficiency is given by PL over PE times 100. All right, so you already have this one, and I already told you the input power is 373. Can you find the output power?
Sir,
Yes.
Could you please help me to the because I can't unmute my mic. I can't mute my mic.
So what I can do?
It's stuck.
I need to mute you, is it? Okay, I think you're mute now. BPP, yeah, it's normal. All right, so proceed. You guys proceed. Can you find the output power? Sumin, can you answer what the output power you get? Sumin, Wan Amir, Tan Li Lun. You guys are silent, huh? I want to hear from you guys. Nur Fatiha, Nur Azlina. Tan got 264.83. Iskandar got 26.45 watt. Nur Fatiha. Just type the answer. No problem. No worry. Okay. No one will know. This is not face to face. Kan? The type je. Don't be shy. Aina dapat 2.6483, Sumin dapat 264.83, Salman 26, Karya 2.65, Fatiha 2.65, Anis 2.64, Rosman, Christian, Caleb dapat 2.64, Faiz, Amanuddin 2.64, Sangira 2.65. Good. That's good. That's very good. That's the response that I want to see from you guys. Walaupun kita bukan face to face, even though we do online, we need participation. Alright, so let's do this. So the efficiency is 0.71. Your input, your output, you don't know. Your input is 373 times 100. Okay, so 0.71 ni dah actually dah divide by 100 lah. So this 100 no need lah. Okay. So your PL goes to 373 times 0.71. Okay. So 373 times 0.71. You get 264.83 watt. Okay, so kalau dia bagi 71% efficiency, baru you use the 100. Kalau dia dah bagi siap 0.71, that means dia sudah divide untuk you lah. It already divide for you. Okay, boleh ya? Dia small question with small tricks je. Kadang question nampak simple with lot of information. Some information we may not use. Okay, you see the information here, you have other information just to confuse you. Okay, some we will really use. Be careful, alright. And next, question B. Determine the sleep of motor when delivering the rated output. Okay, determine the sleep of motor when delivering the rated output. So sleep, kita tahu formula. So can anyone help me? I don't know the formula of sleep. S equals to the 100. Okay, so just now I tell you this is efficiency. Efficiency, if they're giving in percentage, percentage means it will be 71% or 81%. Okay, that will be percentage. Okay, sleep also. Sleep, they give you 5%, they give you 3%, you divide by 100. Okay, so you divide by 100, 3% divide by 100, you get 0.03. Okay, this one 71%, you have 100, you get 0.71 Tapi this one you see here, they already give you 0.71. So this is not percentage. Okay, not unit. You look at the unit, no percentage. So no percentage means you no need to times 100. Okay, no need lah. If percentage is there, then you need. For example, 71%. Let's say it's 71%. 71 equals to PL over 373 times 100. Okay, so now you find 71 times 373 divided by 100 equals to PL. So PL equals to 71 times 373 divided by 100. You still get the same answer, 264.83. Okay, and always remember the output power, the input is 3, right? 373 watt. The output should be almost 70 to 100% lah. Okay, it shouldn't be less than that. Let's say you get answer 2.6 ke 2.64, 26.4. You can see the differences, this answer and this answer. So nampak beza banyak tak kan? Tak mungkin output like this. So the output should be within 70 to 100%. That's the trick, okay. Okay, so the formula, you guys help me with the formula. NS minus NP over NS. Okay, betul. So usually you guys use NP ya. Saya use NR. NS minus NR over NS. Sebab NS ni rotor frequency kan. We have rotor frequency, rotor RPM. Rotor punya speed of rotor. NS is synchronous speed. So I prefer NL lah. So you guys, depends on you guys. So in this case, kita nak tahu NS. NS kita tak diberi. Tapi the speed here represent what? What this speed represent? 1410. Rotor. Okay, pandai. Very good, smart. Rotor speed. You guys, kalau dia kata speed, so usually kita read the rate of speed lah, rotor lah. Okay. And also you tengok number pelik-pelik ni, usually rotor speed. Kalau synchronized speed, dia ikut formula NS equals to 120 times frequency over 4. So yang ni kita akan dapat round number. Example, let's say the frequency now is 50 Hertz. So NS equals to 120 times frequency is 50, volts is 4, 120 times 50 divide 4, you get 1500 RPM. So nampak tak dia punya number? Okay, a round number. Okay, so the sleep is actually sleep equals to 1005 minus 1410 over 1500. To get the sleep lah, 1500 minus 1410 divide 1500. So you get 0.06 and the percentage is around 6%. Okay, so this motor has very poor efficiency, which is 0.71, and very poor sleep lah. Usually sleep tak in real world in real world condition, or you can check the textbook, sleep won't be will not exceed 5%. Okay, it should be equal or less or equal than 5%. Okay, sleep ini kita design soalan kadang kita terlepas kan. Okay, but if anyone asks you to design, so the sleep should be 5%. Oh, sorry, I just saw a lot of messages. Tanya ada kelas tak? ada kelas ada BPP, you guys share the link if any of your friends tak datang lagi, ask them to come. Alright, so you get the 6%. Awesome, very good. 0.06%. Alright, next, nak buat one mark lagi tak? Next question. Okay, similar concept. I think question sama kot. Oh, question sama. Yep, same question. Tak apa, next we proceed with the tutorial. Alright, so this is your tutorial question. I give you 10 theory question. So for theory number 1, explain how a revolving field is set up in 3-phase induction motor. This one, you can look at the slide. The theory is actually given in slide number 14. Slide 14 is the theory lah. Okay. If we double the number of pole on stator of an induction motor, will its synchronized speed also double? Okay. So they ask you, if we double the number of poles on the stator of an induction motor, will the synchronized speed also double? So the question here is, if you increase pole, will it NS increase? So you just find any formula that relate these two. So the formula that relate these two is synchronized formula, 120 times F over poles. So when your poles increase, of course your synchronized speed decrease. Okay, so if your pole decrease, your synchronized speed will increase. Example, okay, when you look at the example, let's say the frequency we fix 50. Now the pole is 4. So what do you get? 120 times 50 divide 4, you get 1500. But if we double the pole to 8, so 120 times 50 divided by 8, you get 750. And S. So when you double the number of pole, your synchronized speed is actually decrease. Okay, it doesn't increase. So that's the common lah. Okay, done. Okay, number 3. The motor of an induction motor should never be locked while full voltage is being applied to the stator. Why? This is actually lock rotor test. Okay, to understand this better, go to your textbook, page number 277. Okay. Okay, so this is your textbook. Go to the page 277, and this is the theory, lock rotor characteristic. So when you use the lock rotor current is 5 to 6 times the full load current. The lock rotor is actually similar to the concept that we do open circuit and short circuit. So usually the lock rotor current will be higher. Okay, the full load, like compared to the full load current. So when you have a motor and you put a load to run on the motor to run the load, let's say conveyor system, you connect the motor to the conveyor system. So it's actually compared to that, lock rotor means you are actually using some things to hold the rotor to prevent it from spin. So the lock rotor current is 5 to 6 times than the full load, okay, making the IR square losses 25 to 36 times. Okay, so when you look here, it's actually, red color, it's okay lah. 20 current is full load. Oh my god, what is happening? Making it 25 to 37 higher than the normal. So this is the theory lah. Okay, the rotor must be therefore the rotor never remain locked for more than a few seconds. So if you want to do the lock rotor test, it shouldn't be more than few seconds. If not, your rotor or your motor will start to burn out lah. Okay, so that's the theory here. All right, so let's proceed. This one done. Next, what does the rotor of an induction motor turn slower than the revolving field? Why? Why does the rotor of an induction motor turn slower than the revolving speed? So the concept of revolving magnetic field lah. Ini yang slide number 14 also lah, the same lah. Okay, so when you have a three-phase current, okay, three-phase current that energize the the pole that energize the stator poles, and your stator pole will have its revolving magnetic field, which we call RMF, and this RMF will induce current in your rotor. Okay, and the induced current in the rotor will have its own magnetic field, which we call BR. This one BS. So when this act on this, it will have a torque. That's why we say torque of induction motor is BS. Okay, BS times BR. Okay, so the motor will start to rotate. However, when this rotor becomes same speed with RMF, there won't be any BS acting on the BR because both are in line. If both magnetic field are in line, there won't be any repulsion. Okay, so for example, north and south, so you have a magnetic field and you have another opposite, north south, you will have repulsion, right? If it is inversely, okay, there won't be any repulsion, right? Only attraction. So in this case, we don't have, in this case, you need to have repulsion. So in order to that, you need to have slip lah. Okay, if it is equal, there won't be any stator magnetic field that acting on the rotor current that induce BR. So BR tak induce langsung. Okay? Boleh faham konsep Kan Okay, I can, no problem. So the concept, so let me if better if I can have any video. Okay, tak apa, I have this image. Everyone can see this image? Alright, so when you look here, so initially you have three phase, just ignore all those right now. So we just imagine the concept of motor, and let's say here I have three phase power, inside here, here and here. Okay, 3D lah. Phase 1, phase 2, phase 3. And when you have three phase power and you have a stator, so basic concept okay, any conductor, okay, conductor, when you put current, when you connect to a current, when the current flow, you will have a magnetic field around the conductor. So the magnetic field, which is given by terms. Okay, this is the Faraday theory. Okay, and this is the magnetic field around a conductor. So any wire that has any current flow on it, you will have a magnetic field around it. Itu konsep biasa. So when you have a winding here in the stator and you have a three-phase power that going in, three-phase voltage, so this voltage will induce current on the winding, and you have a magnetic field, okay, magnetic field that is actually looking like revolving. So that means the current here will flow first, followed by this, up, down, right? So you will have like a revolving magnetic field here. So now this is like a virtual magnetic field, which we call it RMF, rotating magnetic field. So this magnetic field ni, DS, okay, will induce current, okay, current. Ini Faraday law, Faraday law will induce current on the rotor, will induce current here. So when you have current that flowing here, okay, and this is the rotor squirrel cage kan. So when you have current here, and this current similarly will have its own magnetic field. So this magnetic field will actually oppose to this magnetic field, and you will have a torque BS times BR. So BS will actually oppose BR. Tapi when these two spin at the same speed, the magnetic field here couldn't cut the rotor. So tak ada induced current here. So eventually tak ada lah magnetic field. Kan? Even though, okay, finally what will happen? This becomes zero. It will slow down. And when it slow down je, the magnetic field will start to cut again. There will be a magnetic field and there will be slip. Okay? But when it go more speed than synchronized speed, no current will induce, or eventually it will slow down. Okay, itu teori dia. Okay, to understand better, look at the video lah. Ada video I share kan. Okay, so I just proceed to the next slide. Alright. Okay, that's the concept. Awesome. Maybe if you understand. Very good. Okay, next. What happened to the rotor speed? Nidan. What happened to the rotor speed and rotor current when the mechanical load on the induction motor increase? Number 5. What happened to rotor speed and rotor current when the mechanical load on the induction motor increase? So that means mechanical load means kita letak load kan dekat bahagian rotor tu. When you increase the load more, what will happen to the speed and the current? Okay, so this is actually more towards active power flow lah. Okay, to understand better, you look at your textbook, page 276. The textbook. Okay. All right. So look at the page 276. Motor under load. Okay. So you look here. When the motor is under load, the current in the rotor produce a MMF which tend to change the flux. Okay. This set up an opposition current flow in the stator. The opposing MMF of the rotor and stator are very similar to the opposing MMF. Okay. This is the theory lah. Okay, the total reactive produced in the flux is greater than motor. However, when active power is absorbed, the motor increase almost direct proportional to the mechanical load. So, however, the active power absorbed by the motor increase in almost direct proportional to the mechanical load, it follow the power factor. So, motor under load, when you have motor under load, the rotor speed will decrease. Okay, because rotor speed is actually when you increase the load, rotor speed is involving, right? Yeah. Okay, so motor improve dramatically in the mechanical load increase. Okay, at full load is 0.8 for the small machine. The efficiency of the full load, particularly high, can attain 98%. Okay, that's the theory. Mana lagi? What would you recommend using? Okay, ini interesting question. This is one of the interesting question. You guys, let's go to the question number 6. Sorry, mana slide dia? Okay, so you guys look at the question number 6. Will you recommend using a 50 horsepower induction motor to drive our 10 horsepower load? Okay, so let's start a poll. You guys answer. Will you recommend using 50 horsepower induction motor to drive a 10 horsepower load? Who say yes? Who say no? Half say no, half say yes. Oh, super equal now. Six more students. Faster, faster, answer the poll. It's almost tied down. Yes and no. Half yes, half no. Three more. Who say yes, who say no? Adib, Arif, Ahmad Irfan. Come on, we are waiting for you. Adib Fidaus, Ahmad Irfan, faster, faster. Okay, don't tidur good. Anyway, let's publish the result. Okay, you guys can see 20%, 24 of you say yes, and 19 of you, which is 42%, say no. Okay, so what do you think the answer is? The answer is no. Okay, will you recommend using 50 horsepower induction motor to drive a 10 horsepower motor? The answer is no. Okay, the reason is you have huge 50 huge horsepower, but the load here is 10 horsepower. If I ask yes or can, of course yes. Okay, if I ask the 10 horsepower motor can actually run 10 horsepower, 50 horsepower motor run the load of 10 horsepower, of course the answer is yes. Everyone is betul. Okay, however, to use 50 horsepower motor to run 10 horsepower load is actually waste of energy. Okay, it's like you are using over energy lah. Okay, so the power factor, it will actually affect the power factor because the higher the horsepower of motor, higher the power factor. Okay, so you use higher horsepower motor to run small load, you will have high power factor. High power factor means you have a lot of loss reactive power kan. So you have to pay penalty and more. Okay, so that's the theory. Yeah. Okay, next we proceed. Give two advantages of wound rotor motor over squirrel cage. Yang ni Adib, because you are away just now, you answer this question. Give two advantages of wound rotor motor over squirrel cage. Mana Adib? Adib Fidaus. You answer this question. What is the advantages? Jumpa tak? Anyone can help Adik? What is the advantages of one rotor motor compared to squirrel cage? Okay. Speed can be controlled easily. Use less current. High capacity of overloading. Okay, the answer is at your textbook. Your textbook, page 284. So the answer is here. The answer is here. So I just color it lah. Okay, this part. Pas color dia keluar. Alright, so this is the answer. Okay, the lock rotor current can be drastically reduced by inserting 3 external resistors. Okay, so starting current, it can be lock rotor current. So nevertheless, lock rotor will still be high as of the squirrel cage. Okay, but still can be reduced lah. So high starting torque. When you start the wound rotor, you'll have high starting torque lah. The speed can be varied. Betul. Most of you answer this. The motor is ideally suited for accelerate high initial load. So I say high torque, right? So initial high torque means you can run high initial load lah, which require a long time to bring up the speed. So heavy load punya super heavy load, you can use this motor lah, wound rotor. Alright. Next, how can we change the direction of a 3-phase motor? Yang ni macam mana pula? How do we change the direction? Tak susah. So concept is simple. So when you look here, you guys can see the YouTube picture here kan? Okay. So usually you just change. You guys can hear this? Okay, so it's okay, you cannot hear, but I can explain to you. Okay, you can see the picture here. You guys can see the picture here. Okay, awesome. All right, so when you look motor here, every motor you have connection, right? You have phase 1, phase 2, phase 3, the red phase, blue phase, green phase, something like that. So you have 3 phase. So usually when you want to run motor in one direction, you connect all 3 phase accordingly lah, phase 1, 2, 3. But you want to reverse the direction, you just change the phase of the 2 phase out of 1 lah. Any 2 of these you change inversely. Okay, so the, from directly here, you just change this one going to the other point and this one going to here. So this will start first, phase 3 will start first, phase 2 will maintain, phase 1 now will become this one, kat bawah. Okay, so when you change the ABC here, instead of motor spinning this side, the motor will spin this side. Okay, that's the concept lah, very simple. So you use contactor, you just change lah. Alright. So reverse direction three phase for what actually? Okay, good question. So you want to reverse the direction of three phase. Okay, one, usually you want the conveyor to actually go in the reverse direction lah. Okay, maybe sometimes conveyor goes in one direction, maybe you want to change, or sometimes you want to stop the motor. Okay, usually from you want to stop an induction motor that running in a speed. Okay, you should use this concept lah. So what you do, instead of stop, bukan terus power plug your motor, okay? Usually we don't do that. What we do, we call it plugging. The concept is plugging. So what do you do? When your motor is actually running in a high speed torque, okay, you just reverse the direction. It will reverse, and eventually when it comes to a point where your synchronous speed and the rotor speed are zero, you stop the motor. Okay. You can use control power electronic if you want to change the motor in a consistent direction lah. Constantly changing direction, you can use power electronic. Kalau contactor is manual. This is contactor concept lah. Contactor ni macam switch. So this is manual. Okay. If you want to change direction using manual, you use PLC. Program logic control, or you use power electronic. Okay, so these two methods, okay, you will learn in your mechatronic. Okay, in final year you have course, you are the subject name mechatronic, you will learn that. Usually EPM ni will be applied for your control system and mechatronic course. Alright. Okay, next, let's proceed next. Okay, both the voltage and frequency induced in the rotor of an induction motor decrease as the rotor speed up. Explain. Both the voltage and frequency induced in the rotor of an induction motor decrease as the rotor speed up. Ini concept. This is the concept that I explained to you. Remember the concept of inductance. Okay, inductor initially in a concept, in a circuit. Okay, in a three-phase circuit, when you have an inductor, when you have resistor. Okay, when you have inductor alone. Okay, before you install your resistor. So let's say your circuit, you have inductor alone. Okay, you will have a impedance which is JXL. So XL equals to what? XL equals to 2 pi F. Okay, so your inductance which is influencing your phase. Your phase, your voltage and the current phase won't be in line. Voltage and the current won't be in line. Okay, it's distorted by 90 degree. However, when you have a resistor, okay, so now your impedance become R plus JX. So now your R, if you increase the value of R, okay, to a certain value, your R usually R, V and I in phase kan. So when your R is increased, the resultant impedance will have lower phase difference. So when you have lower phase difference, very good lah kan. Starting resistance will be you will have a current that in phase. Okay. Similarly, in this case, when you have both voltage and frequency induced of rotor induction motor decrease as the rotor speed. Okay, so voltage and frequency of induction motor, rotor and induction motor. So you use this concept lah, 2 XL, so 2 pi F. When your frequency is actually high, okay, this one is high. When your frequency is low, your inductance is low. So when you see the formula, F equals to SF. This one is the formula for the rotor frequency lah. Okay, FR equals to SF input lah. So let's say sleep is within 5%, so 0.05, and the frequency input is 50 hertz. Okay, so 0.05 times 50, you get around 2.5 only. So the rotor frequency is around 2.5 to 5%. So very low, the rotor frequency. It will, this the reason why your inductance also reduce. Okay. Next, will a three-phase motor continue to rotate if one of the line become open? Will the motor be able to start on such line? Okay, ini the important one of the important question. Okay, will a three-phase motor continue to rotate if one of the line become open? Will the motor be able to start on such line? What do you think? How many of you say it will run? How many of you say no? Kita buat poll balik lah. Okay. Question now is, will a three-phase motor continue to rotate if one of the line become open? Will the motor be able to start on such line? So we just have yes or no lah. Kita ada three phase kan? Kita ada three phase input line. Kita ada line 1, line 2, line 3 kan? Line phase 1, phase 2, phase 3 kan? So tiba-tiba one phase tu putus. What will happen? So do you think the motor will start to will continue to rotate or no? Okay, most of you say yes. So most of you say yes. Okay, the answer is okay. This the concept what we call it as. Okay. So we call it the concept name is blowing fuse lah. Okay, so you have three phase. Okay, on the stator, and this is the rotor. Imagine you have phase A, phase B, phase C. Tiba-tiba je you are 1, 2, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so you have three phase lah. So this one connect to this one connect to this one connect to this. Tiba-tiba one phase is out. This one we calling blowing fuse lah. Okay, you still have two more phase. However, okay, when the one phase become faulty, okay, out of three phase, okay, the motor will still rotate. So true lah, yes, it will rotate. However, okay, however, okay, the motor now draw current, okay, draw current, more power, we call it power, more power from the other two windings, okay, which will make the motor to run, which will make the motor to run. So out of three phase, single phase gone means the motor will still run, but it will try to take the power using two phase lah. The winding here will be overloaded because it want to compensate, right? However, the motor vibration will increase. However, ini bukan concern kita, vibration not our concern. Ini kita belajar dekat third year. When you guys go third year, there's a course named vibration. Itu bukan our concern. Our concern here, when out of 3 phase, single phase gone means you still have 2 more phase, but these 2 phase draw more power, which eventually make the motor to run, still run. Okay, however, since the winding rating ni not suitable for heavy current kan, more than the rated, so this will become overheating and burn out. Okay, burn out, so failure lah, motor failure. Alright, so that's the theory lah. Okay, so ada banyak sebab your motor can go fail. Alright, it can be one phase, satu phase gone. It can be overload. It can be many reasons. Okay. Alright, so let's proceed. Now let's go to the normal calculation question. Before we go there, you guys have any question? Maybe yes, but slower. So what does it mean by start on such lines? Number 9. Let me check. Number 9. How the both voltage and frequency induced in the rotor of an induction motor decrease as the rotor speed up. Okay, so both voltage and frequency induced in the rotor, okay, of an induction motor decrease as the rotor speed up. Okay, so ini concept inductance lah. So we are saying that inductance, right, mutual inductance, and every mutual inductance are given by the formula of XL equals to 2 pi F. Okay, so the voltage and frequency induced in the rotor will reduce because your frequency from the formula for rotor frequency is slip times input frequency. This input frequency, when you do this formula, this rotor frequency is actually dropping. Okay, so when your frequency is drop, FR, rotor frequency, when you times with 2 pi F, you will get a lower XL. Okay, so let's say initially your motor having higher slip. That means motor is just starting. So we know the concept, slip equals to kosong dengan slip equals to 1, right? Slip equals to 1 is rotor speed is equal to synchronous speed. Slip equals to 0, your rotor not spinning. Okay, so initially your slip equals to 0, then increase 0.1, increase 0.2 until 0.9. Example. So what will happen here is your frequency will start to reduce because the slip is 0.0 means your frequency is 0 lah. Okay, and your followed by your slip. Your slip is now 1 means your frequency will follow the input frequency. Okay, if your slip is 0.9, it will reduce. Okay, so when your frequency, when your slip changes, frequency times here your input frequency changes. So that is actually, okay, so voltage and frequency induced in the rotor of an induction motor decrease lah. Okay, when the rotor speed up. Okay, so your rotor NR equals to no, not NR. So NR slip equals to NS minus NR over NS. So that's the formula. Okay, so when this start to increase, okay, your slip is influenced and this will influence the frequency here. So that's why we say voltage and frequency induced in the rotor will start to decrease lah. Alright, and second thing, the voltage induced also, because your motor speed increase, right? When your motor speed increase, the EMF induced in the rotor will be reduced lah. You remember I said the stator will have its own magnetic field that induce voltage in the rotor. But when the rotor has its own magnetic field and oppose, okay, you will have a torque. However, during the starting initially, your rotor stand still, the maximum induced voltage will be happening there, okay, and it reduce slowly as your rotor start to spin, okay, and when it speed up, okay, the induced voltage will reduce. That's why here we use the theory voltage decrease as the rotor speed up, okay. Similarly, frequency decrease because the formula here. What if two phase open at the same time? What if two phase open at the same time? You still have one phase and your motor will become super not stable, eventually overcurrent and burn out. Okay, so that's the case lah. Alright. Okay, before that, before we proceed, kita buat advertisement sikit. Kita berehat sikit. Okay. Guys, I want to ask you, what is your impression on online delivery and online assessment? How do you find so far? Okay. Do you guys enjoy staying at home, studying, online delivery, online assignment? No. Okay, some of you say no, some of you say many distractions. Okay, I understand. Okay. Okay, so I want to ask you one question. No. Okay. No. Okay, got it. So I want to ask you one question. Listen carefully. Okay. Our education system is actually when you our what we say our ambition, what we offer to you is outcome-based education. Okay, so outcome-based education means the output is matter, the process doesn't matter. Okay, so doesn't matter we are using online or this is question. Okay, listen. Okay, the output is matter here, where doesn't matter it's online or face to face or we are meeting. We have a virtual lab or physical lab. As long as you attain or you understand your course outcome, that's the important thing. So outcome-based education means process we neglect. The process can be anything. However, the outcome should be there. You should attain whatever it's supposed to be attained. So that is the concept lah. Okay, that's the Malaysian education system. However, I want to ask you, is it applied here? Do you think you have some understanding level that equal to face-to-face? Do you think will it better during the face-to-face or online, or doesn't matter?
Personally, I think it's face-to-face is better.
Okay, so you guys think face-to-face better. All right. Let me proceed to. I need some data here. I need your support to give this, to help on this data. Okay, I'm collecting data here. Yeah. Okay, so everyone can see the Mentimeter. Please help me to answer. Go to menti.com 490935. Okay. Do you prefer online delivery over traditional face-to-face lecture? Online assessment is the best way to monitor your progress. What do you think? Do you agree means 10? Strongly agree lah. If you not agree, you give 1 or 0. Or if you think normal, you give 5. Okay? Please help me to answer this survey. I just want to understand better. go to 4905. 490935 www.menti.com. Please, everyone, you are 45 students here. Please help me to answer. I genuinely need this data to do some research on the what do you call this scholarship of teaching and learning lah. So we want to understand better how students are doing in online delivery and traditional face-to-face. Does it the system or any delivery assessment technique are influencing your result? If yes, why? So those are the questions that arise lah. Okay, so when you answer this, also take in mind, last time I received some when I talk to some group of students, usually every batch kalau face to face kita ada bootcamp semua, so I usually you guys will meet me lah. I'm the bootcamp organizer kan. So what we'll do, we will discuss, and some students they say during the face to face kan, okay, so I have a lecture in the class face to face, and after 2 hour lecture I went back, and you guys after the lecture kan balik rumah, when the test come, your only nearest reference is your friend, okay, your friend and your slide, not the lecturer itself lah, because saya dah deliver lecture and I go back, no one record nothing, okay, so your only reference is your friend, okay, so it can be sometime good and sometimes can be bad. However, during the online delivery, my video, everything recording is there, okay, even though I leave, you can still go back and watch the video. So how do you find that? Do you think is it better or no? Still on face to face is the best. What do you think? So keep your answer. I have next question. Nanti I dekat menti-menti nanti tolong jawab. Okay, so let's go to the second question. Let's go to the second question. What do you prefer, online delivery over an assessment over traditional? If you say no, then just answer no and the reason why. If you like online delivery, tell me the reason why. Give some reason boleh lah, tolong lah kan, because I want to study more better kan. It's easier to conduct a discussion on campus. Okay, the video is just one-way platform, so I could just do the same with YouTube. Oh, who else? It depends, but it make me depend on the technology. That's the only thing good about online. got video recorder. We can revise back the lecture if we didn't understand. Now nice and face to face. Because we can't focus 100%, so you can't see us. It's easier. Okay, no. Yes, and the reviews are not like it doesn't necessarily require lectures to record online. Macam-macam answer ada. Some prefer, some not prefer. Very good, very good. Okay. Okay. So siapa lagi? Tolong hantar. Please answer. Do you prefer online or face to face? And why? Right. So far 34. Okay lah. Alright. Thank you. Thank you so much. Macam-macam answer. Anyway, let's proceed. I hope next semester we can meet in campus and we can have a face-to-face class lah. Alright, so I wish all the best for you guys, and in future, I think based on your answer, some of you prefer online, some of you prefer face-to-face, and I thought maybe blended learning, which is including face-to-face and online, okay, maybe some point online, some point face-to-face will be helpful, will be better. Okay, so let's proceed, guys. Now kita continue. Focus balik. Take out your paper. Take out your notes. Okay, so the question here is a 3-phase 20-pole induction motor is connected to 600 volt, 60 hertz. Okay, what is the synchronized speed? Okay, so I already give the answer, so you just show me the step lah. Okay, so what you do, you have 3-phase 20 pole, so the pole is 20. Okay, you have 600 volt and the frequency equals to 60 hertz. So the synchronized speed is 120 times frequency over number of pole, you get 360 RPM. Okay, if the voltage is reduced to 300, will the synchronized speed changes? The answer is no, because the formula, which is Ns equals to 120 F over P, doesn't affected by voltage. So if you increase or decrease your voltage, doesn't matter, it doesn't influence your synchronized speed. How many group? This one no need lah. This part we just ignore because I didn't go for the design part kan. Design part I left. Okay. So next, calculate the approximate value of the starting current, full load current and no load current of 150 horsepower. Okay, so ini let's look at the textbook first before we proceed. Okay, so let's go up. Okay, so ini the formula. Okay, estimating the current in an induction motor. The full load current of a three-phase induction motor may be calculated by the mean of the approximation I equals to 600. PH is the horsepower, horsepower over voltage. Okay, PH is the output power in horsepower. Okay, and E is the rated line voltage, I is the full load current lah. 600 is the empirical constant. Okay, recalling the starting current is 5 to 6 and at no load current lies between 0.5 and 0.3. So you have for 6 for the starting current. Okay, the starting current it can be 5 or 6 lah. Alright, and for the no load current it can be 0.5 or 0.3 depend on the motor condition. For example, let's say calculate the approximate full load current, lock rotor current and low load current in equation there example. Okay, so full load current, the formula is given. I equals to 600 horsepower times line voltage. The line voltage, the horsepower is here, the line voltage is given. So you just use P horsepower over line voltage. 600 is the constant, empirical constant. So you'll get this value. Okay. No load current, you use the no load current, you have 0.5 and 0.3. But in this case, your motor is a huge motor. Huge motor, so we have formula. Okay. Small motor, okay. No load current, you use 0.5. Big motor, you use 0.3. Okay. No load current lah. Lock rotor, okay. For small motor, you use 5 to 6 lah. Okay. For big motor, you use 4 to 6. Usually, small motor kita guna 5. For the big motor, we use 6 lah, 6. Alright. So this is big motor. Okay. Why I told you big motor? So what is the difference between small and big? Small motor should be less than 5 horsepower. Anything big than anything larger than the 5 horsepower is a big motors. Okay, in this case, this is big motor, so you use 0.3 times the starting current lah. Starting current is a full load 130. So 0.3 times 130, you get this value. The starting current lock rotor equals to 6 times because this is the big value, right? So we use the 6 value here, 6. Okay. And the apparent power, the apparent power under lock rotor condition is given. Apparent power equals to root 3 EI. Ini formula for the motors. For motors, apparent power is given by S equals to root 3 EI. Root 3 times input voltage times the current here, the starting load current, you get the apparent power. Okay. So when the power of motor is expressed in the kilowatt related to mechanical output and not the electric input, the nominal rating of the power expressed in SI unit. So you just change it to kilowatt lah. Okay, so 500 over 1.34 is 373 kilowatt. Okay, so that's the information. And next, we want to look into the active power. Okay, in motor, okay, you have power distribution lah. Okay, when you have power supplied to the motor until the power transfer to the load, we can actually calculate, and there are losses along the way lah. Okay, so to calculate that, okay, so to calculate that, active power to stator, we call it PE. This one we call it PE, active power to the stator. Okay. Next, you have power losses at the stator. So stator body kan metal. So you have a stator power loss, I square R. Sorry, iron losses is the metal because of the stator lah. Ini all because of this. Okay, however, the I square R losses is the winding here. This winding is the I square R losses. So you have two type of losses in the stator. One is the body and the one is the winding. Okay, the body we call it iron loss, PF, and the stator winding loss is JS. The input power is active power lah. We call it the active power used by the motor is PE. That's the input. And all this, the PE minus this will be transferred to the rotor. So you will be transferred to the rotor. So now this is rotor active power, and in the rotor you have losses also. You have rotor punya winding losses which is I square R. So this one we call it PJR lah. Yang tadi PJS winding dekat rotor, dekat stator, ini dekat rotor. Okay. From there, the input power, active power to the rotor minus this, you will get the mechanical power. So this is the mechanical power, and the mechanical power have windage and friction losses. Ini due to the belting lah. So motor kan kita bukan direct guna the motor. We usually connect the motor to a belt. We usually connect to a gear. So you have a loss through that. So that one we call it windage and friction losses. And finally, the power that transferred to your load is actually shaft power. Okay, so this is the output power. This is input, this is output. So you total 8 component involving here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and there's a way to find each component. Okay, the first efficiency is given by PL over PE. PL is the output, PE is the input. Efficiency is given by PL over PE. Boleh ya? Why can't we change P equals to VI? Untuk apa pula? Cheer for what? You want to change P equals to VI? For this, we want to use, actually this is the P equals to VI, betul. Tapi this, we have a formula for estimation current in the motor. So we have this empirical value 600. So 600 times horsepower. This is actually power equals to E ni kalau pergi sini dia actually VI, betul lah. P equals to VI. Tapi kita ada derivation, kita ada approximation lah. Okay. So this part okay guys. So efficiency is okay. Next formula is I square R losses in the rotor. So I square R losses is this one lah. In the rotor is PJR. PJR, dia punya formula dia simple. Slip times PR. To find these losses, you take slip, you times with the PR, you will get PJR. Okay, PJR is actually I square losses. Slip, you know the slip lah. So PR is the power transmitted. So this power, this one times slip, you will get this. Okay, so that's the formula. However, okay, number 3, PM, mechanical power. So the mechanical power actually PR minus PJR. So to get this, you have to take PR minus PJR. You will get this lah. Okay, so for example, to get PR, you take PE, you minus these two, you get PR. PR, you minus this, you get PM. PM, you minus PV, you get PL. Okay, the arrow yang up to, you minus. Okay, this one is the resultant power. This is the losses. Okay, so the mechanical power is actually PR minus PJR. And kita boleh kata tadi, kita kata PJR equals to SPR kan. We can use this formula. We can take this and replace inside. PJR kan equals to SPR. So you put here. So now PR, you take out the PR, you put 1 minus S. So you have two formula for PM. Use either you find PM equals to 1 minus S PR or you use PJR equals to SPR. So ini nanti kita akan tahu, kita akan tengok cara nak buat. Okay, next, motor torque. Torque is given by 9.55 times mechanical power over rotor speed. Okay, so kalau you guna mechanical, you guna rotor speed. Kalau you guna 9.55 rotor power, you guna synchronized speed, NS. Okay. Okay, let's look at the example. Okay. To understand better, let's look at the example. Yes. Let me copy the question. Apa ada kat sini? Okay, so before that, let's finish this question first. Number 12. So number 12, how do we do that? Number 12, you know this is 150 horsepower and this is the 575V and we got 60 hertz. 60 hertz. No, we got 3 phase. Okay, so this is the information we have and we know this is huge motor. 150 horsepower is bigger than 5 horsepower, right? Okay, 5 horsepower. So this is big motor. So the things that we're going to use is 6 and 0.3, the empirical unit. So to find the starting current, the I here equals to 600 PH over E. So 600 times 150 over your input voltage 575. You get 156 ampere. Okay, ni alright, ni boleh. So I'm doing this question. So okay, so you will have this, and next starting current. We know that this is 6 because big motor, right? 6 times 156, you get 936 ampere. And for the no load current, you use 0.3 times 156, you get 46.8 ampere. Okay, so this is a lock rotor current. Okay, so that's number 12. Tutorial question number 13. Calculate the synchronized speed of 3-phase 12-pole induction motor that excites 60. So this is 120 times 60 over 12. You get 600 RPM. Okay, what is the nominal speed if the slip full torque is 6%? Okay, so S equals to 6%. Now this is in percentage, so you convert to 6 over 100, you get 0.06. So 0.06 equals to NS minus NR over NS. So your NS is 600 now. 0.06, 600 minus NR over 600. Okay, so you get NR equals to 0.06 times 600, and then you 600 minus the whole answer. So you get 94, is it? 0.06 600 and 600 minus answer. You get 564 RPM. Okay. Next. Okay, so this is the real question that we're gonna apply all the theory that we studied just now, the active power flow. So we're gonna apply all the active power flow concept. Okay, so again, let's write the formula that we know. We know the efficiency equals to PL over PE. And we know PJR equals to SPR. We also know PM equals to PR minus PJR. And PJR equals to SPR, PR minus SPR, because we replace in this value. This is 1, this is 2, 1 into 2, 1 into 2, you get this. And when you factor out PR, 1 minus S equals to PR. So you can use this formula, PM equals to 1 minus SPR. And you also have formula, what else you have? PM equals to, PL. Cari PL, you just take PM minus windage and friction, PV. This is PV. Okay, so quite messy here. Let me padam. Let me erase this. Padam ni. So when you look here, active power to stator we call PE. Stator copper loss is P what? Copper loss is what? Copper loss is PJS. Stator iron loss is PF. Stator active power is PR. Rotor copper loss is PJR. Mechanical power is PM. Windage and friction loss is PF. Finally, you'll get the output which is PL. So to find PM, you can actually, to find PL. To find PL, you can take PM minus PF. To find PR, you can take PE minus PJS minus PF. To find PM, you already take PR minus PJR. Semua dah dapat. So this is the concept that you can apply lah. However, active power flow, you must remember you have 8 components. First component, input power, and you have 1 losses. The first losses is PJS, followed by second losses is PF, and then you will get the rotor power, active power supply to the rotor. And active power supply to rotor has rotor copper losses, and you will get the mechanical power. And this mechanical power will have losses in terms of windage and friction. To finally you will get the PL. Overall you have 8 components. 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8. Total 8 components. Remember this, this is important. Okay, so we want to use that concept lah to answer this. Want to use this concept to answer the question. So the question given you, a large 3-phase 4000 volt 60 Hz squirrel cage induction motor draw a current of 6 ampere and total active power 2344 kilowatt when operating at the full load. The corresponding speed is accurately measured and found to be 709.2. The stator is connected in Y and the resistance between two stator terminals is 0.1. The total iron loss are 23.4 kilowatt. Okay. So before we do tutorial, tutorial ni susah sikit. Kita buat soalan dekat buku teks dulu. Bagi you guys understand step by step first. So, can you see the question? A 3-phase induction motor having a synchronized speed of 1200 RPM. Okay, draw 80 volt, 80 kilowatt from a 3-phase feeder. The copper losses, iron losses is stator amount to 5 kilowatt. If the motor run at the 1152, cut the following. Ini question dia. Question dia simple je. Question dia kata 3-phase induction motor. Okay, dia punya synchronous speed dia dah bagi dah. Dia bagi PE dia kata draw. The motor draw 80 kilowatt That means active power ke draw ke semua dia punya PE. Dia dah bagi PE. Okay, and the copper losses and iron losses ni PJS, iron losses ni PF. In the stator, amount to 5 km, dia dah bagi dah. Yang ni campur yang ni 5 kilowatt, dia dah bagi. Okay. If the motor run at 1152 RPM, so ini apa rotor speed, right? This review, okay? Can understand? Proceed, Alright. So the active power transmitted, they want you to find active power transmitted to rotor. Apa benda ni? Active power transmitted to rotor is what? PR kan? Boleh tak faham? Active power transmitted to rotor is PR. The rotor I square R losses. The rotor I square R losses is PJR. Okay? Dia minta lagi. The mechanical power is PM. PL equals to PM minus VF. PL equals to PM. PL equals to PM minus PV. PV is the windage and friction. PF to iron losses at the stator. Okay. Inilah saya type. Kita type. Saya type and you guys also write in your copy. P is input if power. Okay. PE equals to input active power. Kita ada PJS. PJS equals to stator copper loss. PF. PF equals to apa kan? PF equals to stator iron losses. Okay. Lepas PF kita ada PR. PR equals to active power to rotor. Okay. And then kita ada PJS. PJR. PJR is rotor copper loss. Lepas tu kita ada PM. PM equals to mechanical power. And kita ada PV. PV is friction and windage losses. Friction and windage lah. Alright. And finally you have PL, which is shaft power. Also known as output power. Okay. So no confusion, I hope everyone understand. Alright, so let's proceed. Kita nak cari active power transmitter to rotor. So active power transmitter rotor, formula dia PR equals to PE minus PJS, stator punya copper loss minus stator punya iron loss. Tapi kat question dia dah bagi both is 5 kilowatt. So you take PE input power 80. Kat sini dia kata active power 80 kan, draw 80. So 80 minus 5 you get 75 kilowatt. Okay, next kita kena cari slip. Sebab kita tahu the rotor I square R losses PJR is actually given by formula PJR equals to SPR. So nak cari PJR, kita kena ada slip. Slip ni synchronous slip dia bagi 1200, rotor speed dia bagi 1152. We divide this, you get 0.04. So rotor I square R losses are PJR equals to SPR. You dapat this value. Okay, next dia kata find the mechanical power. The mechanical power equals to PR minus the rotor I square R losses. Kan? So when you look at the formula, PM equals to PR minus PJR. So kita nak sekarang the mechanical power. PM equals to PR minus PJR. PM tadi PR kita dapat 75, PJR tadi dapat 3, 75 tolak 3, 72. You get the PM. Once you get the PM, you can find the power deliver, the mechanical power PL deliver to the load. So dia nak PL. So you want to find PL because dia nak cari knowing the mechanical power deliver to load, windage and frequency loss equal to 2 kilowatt. Dia kata find the power transfer to the load. Dia confuse kita. Dia kata find the mechanical power deliver. So this is actually find the shaft power delivered to the load. Knowing the windage and friction losses which is 2 kilowatt. PV sekarang dah 2. So what you do? You take PL equals to PM minus PV. PM 72 tadi minus PV 2, you get 70. Now can you find the efficiency? Senang je. Efficiency equals to PL over PE. Okay, so efficiency equals to 70 over 80, you get 87.5%. Ini satu konsep. The next concept is, for example, a 3-phase 8-pole squirrel cage induction motor. Okay, they give you speed. Ini synchronized speed. The motor absorb 40 kilowatt. Copper and iron losses. Ini dia dah bagi dah PJS dengan PF. Dia dah bagi dah. Okay, in the stator dia dah bagi dah stator PJS dengan PF. To 5 and 1. So dia kata motor absorb 40 and the copper and iron loss in the stator amount to 5 and 1. So yang motor input adalah 40, motor absorb 40, input power 40. And the copper and iron losses in the stator amount to 5 plus 1. So 5 and 1 lah, copper and iron. Calculate the torque. Ni senang je. Kita ada PR. PR sama dengan PE minus PJS minus R. So 40 minus 5 minus 1, you get 34. Dah dapat PR, kita boleh jadi torque. Torque equals to 9.55 times PR over synchronized speed. 9.55 times 34,000 or 34K divided by 900, you get the torque lah. Senang je pun. It's very straightforward. 9.552 unit. But torque ni dia ada formula. It's actually empirical unit kat sini. You look here. So when you look at the formula, okay, PM equals to PM equals to rotor speed times mechanical torque over the factor 9.55. Okay, so 9.55 is a factor. For the torque, unit is Newton per meter, Nm. Yeah, so we continue. Okay, ada banyak soalan lagi kita buat. A 3-phase induction motor having a nominal rating of 100 horsepower, 75 kilowatt and a synchronized speed of 1800. The connected to 600 volt. Okay, though this is the question lah. So they say the induction motor having a nominal rating 100 horsepower, synchronized speed and connected to 600 volt. Ini dah bagi tahu detail. Okay, so ditanya you, okay, the 2 wattmeter show the total power consumption. Total power consumption is 70 watt. So the wattmeter showing the power consumption by a motor is 70. Although the motor horsepower is 75 watt, but the power meter showing the motor are using only 70 input power to run the load. Okay, so the input power sekarang 70 bukan the rating. Motor rating memang boleh guna 75 watt, 75 kilowatt. Tapi when you look here P1, P2, they show you 70 only. And the ammeter indicate the line current 78 ampere. Precise measurement given a rotor speed 1763. Okay. Dia kata stator iron loss is 2 kilowatt, windage and friction losses PV 1.2, resistance between two stator. So you must remember resistance between two stator. So you kena bahagi dua. Yang ni kena bahagi dua. Bahagi dua because two stator terminal. Okay. Dia suruh kita cari power supply to the rotor. Power supply to the rotor PE equals to 70. Sebab kat soalan ni dia kata you use 2 power meter, you get the value is 70. Add up. Okay. So ini the power use. Although the rating is 75, but the motor use only 70 kilowatt. Okay, next. You know the Okay, alright guys. Attendance not compulsory ya, kelas dah habis. Tapi kalau you guys want to stay, can stay. Nak watch video later also can, no problem. Let me proceed Okay, so in this case, now we continue tadi. I told you that if they say any resistance between two stator terminal is 0.24, so you divide by 2. Okay, if 3 stator terminal, you divide by 3. If 4 stator terminal, you divide by 4. Tapi kalau dia tak kata in between stator terminal, dia kata stator terminal je, tak payah divide. Okay, so in this case, the R is 0.34 divided by 2. And you can find the stator I square R losses, which is given by 3 I square R. 3 times the current that given, current is 78 ampere. The resistor is 0.34 divided by 2, you get 0.17. So you get the 3.1 kilowatt. So the iron losses dah bagi, iron losses 2 kilowatt is given. Okay, so now you can find the power supply to the rotor, which is PR equals to PE minus PJS minus PF. 70 tolak 3.1 tolak 2, 64.9. You can find sleep, which is 1800 minus 1763. Okay, because dia dah bagi detail kan, motor detail 1800. So you will get 0.025. After that, the rotor I square R losses equals to PJR equals to SPR is 0.205 times 64.9. Okay, mechanical power developed, PM equals to PR minus PJR, 64.9 minus 1.33. You will get 63.5. The mechanical power PL to the load, PL equals to 63.5 minus PV. PV dia kata 1.2 kilowatt. So you take the mechanical power, you minus the PV, you get the PL. Efficiency is PL over PE. Dah dapat juga. Torque equals to 9.55 PR over NS. Kalau you nak guna PM pun boleh, PM over NR. Kalau PM, NR. Kalau PR, NS. Okay, remember that. You will get this. You will get the same answer. Okay, so this is the concept lah. Alright, ini dua contoh kat textbook. Okay, let's proceed with the example at our tutorial. Okay, so this is our tutorial example. Here, you be given a large 3-phase 4000. So you ada voltage equals to 4000 volt. Apa lagi information yang kita ada? Kita ada 60 Hz. Kita ada squirrel cage induction motor, draw a current. So kita ada current I equals to 385 ampere. Total active power, kita dah ada PE. PE equals to 2344 kilowatt. Kita dah ada PE. And then when operating at the folder, the corresponding speed is actually measured and found to be 709. So yang ni speed apa? NR right? 709.2 is RPM. Okay, ni dah ada. The stator connected in Y and the resistance between two stator. Tengok dia ada bagi trik dah. Stator connected in Y and the resistance between two stator is 0.1. So 0.1 between two stator R. So you divide 2. Okay. So total iron losses. Iron losses ni PF 23.4 kilowatt. And the windage and friction losses PV dia bagi 12 kilowatt ni watt Okay, calculate the following. Okay, dia nak kita cari power factor. Power factor equals to cos theta. We know that power factor equals to cos theta. Cos theta equals to what? The rated power, the usage power, PE over the rated. Okay, the rated power. This is the consumed power. Okay, power factor is consumed power, rated power. Okay, so to find S, kita cari S. Power factor also P equals to cos theta kan. So P equals to, and we know this is actually apalah, S equals to root 3 VI. So root 3 times 4000 times current, you will get the apparent power. Apparent power is root 3 times 4000 times 385. You will get 2667. Okay, 2667 kilowatt lah. Ini yang rated. Okay, so ini yang apparent power lah. Tapi in the active power that consume is 2344. So cos theta equals to active power that consume 2344 over 2667. You get 87.88%. Okay, so 87.88 or 87.9%. Okay, active power supply to the rotor. So what is the active power supply to the rotor? Active power supply to rotor is PR. PR equals to PE minus PF minus PJS. PE tadi 2344. Okay, tolak PF tadi 23.4. PJS belum cari lagi. PJS equals to PJS equals to 3I square R. So 3 kali 385 square because I square R 385 I square times R ialah 0.1 because 2 stator terminal divide by 2. So dapatlah value. You will get PJS is what? PJS you get 22.23 kilowatt. Now minus 22.23, end up getting 2298.37 kilowatt. So dah dapat PR. So if you get the PR, you can find the I square R losses. PJR equals to SPR. Kita nak cari S. Synchronize equals to NS minus NR over NS. Dekat sini dia dah bagi kita information NR. NR is given 709.2. Kita tahu NS tak? Do you guys know NS tak? Do you guys think we know NS? Tak ada. Okay, so memang we don't know NS. However, we can predict what is the nearest value. NS, kita tengok NS equals to 120 times 60 over, kita tak tahu, okay, but we try and error. Try 8. Okay, pole equals to 8, what do you get? So 120 times 60 because frequency dah bagi frequency is 60. Pole kita cuba 8 divide by 8, what do you get? You get 900. 8 means you get 900. Try 10. 10 pole means you get 720. If 6 pole means if 12 poles means you get 600. So you tengok 900, 600, 720. Which one do you think it will be suitable or nearest to this synchronized speed, rotor speed? Yang ni kan 10 pole. Because kita tahu synchronous speed shouldn't be more, sleep should be within 5%. So kalau 900 ke 600 ke, sleep will be very huge. So 720 is the nearest. So guna 720. So find the sleep. S equals to 720 minus 709.2 over 720. You will get 720 minus 709.2 divide 720. 0.015. So sleep you get 0.015. So PJS equals to form, kita kena cari apa sekarang? We need to find this one, is it? PJR equals to SPR. S is 0.015. PR is 2298.37. You get answer times 2297, is it? 2298.37. You get 34.46 kilowatt. Lebih kurang 34.5. Alright, ni dah dapat. The load mechanical power, torque, efficiency, continue lah. You use the formula, okay? Tak susah. So PM mechanical equals to PR minus PJR. Use lah 2298.37 minus 34.5. So 2298.37 minus answer terus, you get 2263.89. 2263.89 kilowatt. Ini PM. Lepas tu cari PL. PL equals to PM minus PV. PM tadi 2263.89. PV dah bagi 12. Tolak 12. So minus 12. You get 2251. 2251 kilowatt. 2251.89 lah lebih kurang. Okay, lebih kurang dah dapat dah. And then apa lagi kita nak cari? So you want to find the efficiency. Anything I miss? Torque. Kita cari torque. TM equals to, kita cari TM equals to 9.55. Kita tahu dia punya PM kan? Kita tahu PM dia 2263. PM, kalau PM kita guna NR. Kalau 9.55 PR kita guna NS. That's the formula lah. So gunalah yang mana patut, tapi saya berminat nak guna 2263 divide by synchronous speed. 2263.89 times 9.55 divide by synchronous speed 709.2. So I get 30.4 lah. 30.5. Kalau saya guna mechanical. Kalau saya guna PR 9.55 times PR is 2298.37 divide by 720. Ini saya dapat 30.5 juga. Okay, dapat dua-dua sama. So the formula is right lah. And then finally efficiency. Efficiency equals to PL over PE. PL tadi 2263 89. Betul ke 2251, sorry. 2251 over 2344. 2251 bagi 2344. So you get 96% lah. 96%. So this is it. So semua dapat. So this how you solve a huge motor power active power problem. Okay, and yalah, semua soalan sama je lebih kurang. Yang soalan kat belakang-belakang tu yang you do until 15 je. Yang 16 tak payah buat. Okay, so 15 dia kata 3 phase motor with load. Dia kata load dia 5000 horsepower. Okay, so PL equals to 5000 horsepower. So tukar horsepower dekat kilowatt. So you can change lah horsepower to kilowatt. You divide 763. Okay, mana formula aku lupa. 763. Yep. Horsepower. So 5000 divide by 1.34, you dapat 3731 kilowatt. Okay, yang ni kalau you nak P dekat kilowatt, dari kilowatt you times 763 kot. Yang ni you divide 1.34, you dapat the value. So now PL is given. Okay, now what else information you have? You have NR to 594, and of course your NS should be 600 from the experience lah. However, you can do 120 times 60 over 12. Sure, you get 600. So now you get this. What is the approximate I square R at rated load? I square R is PJR. Okay, PJR is actually SPR. Okay, so you find the S first. Slip now is 600 minus 594 over 600. You get 0.01. Okay, so slip is 0.01. And now kita ada PL. Kita tahu PL equals to PM minus PV. PV kat sini tak bagi. So usually question tak bagi PV means we have to assume. Okay, and PV usually is given by usually PV 3 to 5% of PL. So 3 to 5% of PL lah. So ini yang formula PV usually equals to 3 to 5% of PL. Ini you remember lah. So in this case now I just assume one value lah. I assume so 3.5% from PL. So I roughly take this is PL is 3731. So 1% is what? 1% is 3.7. So 3% is 9. So almost 9.7 lah. Almost 10 kilowatt. So 10 kilowatt minus PM kita tak tahu. Kita tahu PL is 3731. So PM equals to 3731 plus 10. So you get 3741 kilowatt. PM dah dapat. So now you proceed to find what else you need. You need to find PR. PM equals to PR minus PJR. So ini formula dia. And you know PM equals to PR. Actually PJR equals to SPR. PJR equals to SPR. So minus SPR. So you get PM equals to 1 minus SPR. So now you are cari PR equals to PM over 1 minus S. So you will get PM is tadi 3741 over 1 minus 0.01. So what the value you get? 1 minus so 0.99 lah. 3741 divide 0.99. You dapatlah 3778. You get PR equals to 3778.78 kilowatt. So that is the PR, and you can still proceed lah. Kalau you got the value or you assume, you can still proceed. PR equals to PE minus PF minus PJR. So ini you can assume usually PF dengan PJR given, or you can assume usually less than. Usually PJ and this one is less than 10%. Okay, less than 5%. Ini less than 5%. PV ya, PV usually 1 to 3%. Macam tu lah. Okay. So you guys remember this, and yeah, that's it. And next week kita ada apa? Next week tak ada quiz, semua settle. So we just wait for your submission of your team project. And remember, team project the report you have to submit, and you have to do a video presentation. And test is on Thursday 8 to 10 PM night. Online test as usual, and submission is online PDF. The test is just 1 hour. Okay, you got another 1 hour for submission. Okay, please make sure you don't snap and send other question or the question paper. Please be careful. We don't want things that happen in test 1 to repeat. Alright, that's all the best. If possible, we meet on Tuesday lah. If you guys have any question, you can in Tuesday maybe we can have a chat session in Ulearn or anything lah. Okay, depends on you guys. We chat in we discuss in WhatsApp lah later. Alright, thank you very much. Bye, see you guys.
you